All right, welcome everyone. Yesterday we spoke about the Mars Climate Orbiter, and today is time to talk about a bridge. Not any bridge, a particular bridge, a bridge in, and the clicker doesn't work, and a bridge in between the Switzerland and Germany in this city of Laufenberg. Actually, there are two cities in both countries with the same name, and the bridge connects them. The bridge was built in 2004, and it was started to be built by two teams starting from both different sides of the river. And what do you think? What could possibly go wrong here, right? Well, it turns out that both Germany and Switzerland are using the mean sea level as a reference for the altitude. But, well, you can't see a sea from this point in Switzerland, so they need some reference level, officially some reference point somewhere, right? And it turns out that the Germany is using so-called Amsterdam sea level, which is the level of the North Sea in Amsterdam that was measured through the year of 1683, right? And right now this is official reference zero in Germany as well. And Switzerland is using another reference point. It's called Neptune stone. It is actually a stone that was deposited by the glacier and next to the port on Geneva. And in the year 1902, its altitude was corrected according to the sea level in Marseilles, which is France, next to the Mediterranean Sea, to be 373 meters, 0.6. So it seems that Germany is using sea level, Switzerland using sea level, but those are two different seas. And the difference between sea level between those is 27 centimeters. If you think that was the main issue, it was not, because as the project manager stated, well, the difference of 27 centimeters was certainly known, and everything had been drawn correctly on a paper. So what can possibly go wrong? Well, there was a human error, because it turns out that during the construction, they actually saw that something is wrong, something is off, but it was off more than 27 centimeters. Any ideas? It turned out that, well, there were some calculation errors by design issue that was encountered in the calculations. Instead of adding 27 centimeters in Switzerland, they built 27 centimeters below than they actually were supposed to. So the actual difference was 54 centimeters, right? Well, but it was actually a happy ending because, as I said, they discovered this on time. The Germany built the road lower by 54 centimeters, and eventually the two sides of the bridge connected properly. But of course, you can use physical units libraries to actually not have this issue in production, right? So if you will go to my library on GitHub or to Compile Explorer, thanks to Matgodbot, you can try this out by yourself. So first you need to define the reference points, right? We are defining Amsterdam sea level, and based on it, we are defining then the level of Mediterranean sea level being 27 centimeters lower. And we are defining types for altitudes using those two reference points for Germany and Switzerland. Then we are providing some expected bridge altitude. I'm not sure exactly what is the altitude of the bridge, so I made it up. It's 330 meters, right? But it is measured in any of those reference levels, but it's correct according to this level. And then, of course, as you are building something, you are looking for the nearest landmark. On one side of the river, another one, let's assume this is 300 meters landmark, marked somewhere already by the previous measurements, and you find out what is the base of the pillar on each of the sides. And you compare how it's related to this landmark. So let's assume that there are 3 meters above on one side, 2 meters below on the other side, and you need to beat those pillars to be exactly the same altitude so they can connect over the river, right? So this is the altitude on both sides, and then you are calculating the height of both pillars that you have to build, right? So this is the bridge altitude, the expected one. You subtract the altitude of the base on one side, on another side. Well, print all of this, and you get information that bridge pillar on the Germany side should be 27 meters, on Switzerland 32 meters and 27 centimeters because of the sea levels, right? The bridge load altitude measured in two different reference points, well, it's off by 27 centimeters, but this is expected. And if you take the absolute value, like this one, well, this is exactly the same altitude, and everything connects fine. I'm even having 20 seconds, so I have bonus slides for you. It turns out that you can actually not measured through the mean sea level reference point. There are a lot of documents actually trying to use GPSs and other systems to work and measure altitude. So we want to measure them from the center of the Earth. And when we do, Mount Everest will not be the highest peak on the Earth. Thank you very much.
Thank you.